To find the inverse of a function, well, first we need to look at what that means to find an inverse. So by definition, we look at f of x and f inverse of x are inverses. Then f of a is equal to b if and only if the inverse of f of b is equal to a. Which means basically we should be able to change the x and y positions, and that would be basically finding our inverse. So in this case, we can look at this. F of x you can sometimes think of as y is equal to negative 1/2 x plus 1. So if I want to find the inverse of that, I'm going to take and say, okay, well, x is going to be equal to negative 1/2 of y plus 1 then. And that's my inverse. But then that's not really in our y equals mx plus b form, so we want to rewrite this. So I would subtract 1 from both sides. And so then I get x minus 1 is equal to negative 1/2 x, or y, sorry. And then I would want to multiply both sides by a negative 2. Right, multiply this whole thing by a negative 2. So that would make, distributing that, a negative 2x plus 2 is equal to y. And if I rewrite that in the right form, that would be y is equal to negative 2x plus 2. So then I want to graph those two lines. So I've got basically y is equal to negative 1/2 x plus 1. So my y-intercept is a positive 1. Oops, I should probably use red for this one. And my slope is a negative 1/2. That means I'm going to go down 1 and forward 2. Down 1 and forward 2 to get my next point, or up 1 and back 2. Up 1 and back 2. And then I can draw in my line. And that is my original function, graphed. And then I want to graph my other one. And it has got a y-intercept of 2. And its slope is a negative 2, which means down 2 and forward 1. Down 2 and forward 1. Down 2 and forward 1. Up 2 and back 1. And then I can sketch that line in. And then if we look at this and I draw in my y equals x line, those should in fact be reflections of themselves across that y equals x line if this is a reflection. And we do in fact see that. It would be helpful if I drew that line in better. So why don't I just grab that tool. There we go. And that looks a lot better now that I've got the tool that actually puts the line right across there. So those do in fact reflect across the y equals x line, and so they are reflections. So to find the inverse of a function, you replace the x with the y, and then solve for y, and get your equation in the right form.